A detached garage in eastern Oregon, late afternoon. Inside a steel drum bolted to the floor, a concrete disc spins on a central shaft. Low hum and nothing else. The solar panels went dark 40 minutes ago, but the lights are still on. The refrigerator is still running. This man pays $17 a month to the grid, the connection fee, and nothing more. By the end of this video, you will discover the one number the battery industry cannot afford for you to calculate. Hi, I am Oliver, and welcome to Off-Grid Ohms. Subscribe and hit the bell for more uncovering electrical secrets. I did not believe it would work at this scale. Nobody on the forum did. A retired millwright outside Bend, Oregon, claimed he had been running his workshop on spinning concrete for over 3 years. He posted shaky phone videos of a humming steel drum and screenshots of utility bills showing 0 kilowatt hours drawn. Month after month, the data held up. Nobody could explain it away. So last spring, I drove 5 hours east to see it myself. What I found was not complicated. It was almost disappointing in its simplicity. 2 55-gallon steel drums sat on welded frames inside a workshop behind his house. Each drum held a highly reinforced composite matrix disc about 18 inches across, weighing roughly 60 pounds. The discs spun on sealed ball bearings mounted on central steel shafts. Each shaft connected through a belt and pulley to a salvaged treadmill motor. A charge controller and a small inverter sat on the shelf above. The system powered his workshop lights, a chest freezer, and a box fan. It had been doing it for 3 years without a single major repair. I placed my own clamp meter on the inverter output. Steady current. The sun had gone down over an hour before, and the flywheel was still feeding the house. The only component he had replaced in 36 months was a pair of motor brushes. It cost him $4. He did not invent this. He learned it from a maker's forum online. 3 other builders in that forum had independently constructed concrete flywheel prototypes. One in New Mexico, one in rural Michigan, one in British Columbia. None had engineering degrees, all had trade backgrounds. Welders, machinists, auto mechanics. They were not following a product manual. They were adapting industrial flywheel physics that predates electricity itself to a scale that fits inside a garage. And the science behind it goes back further than any of them probably realized. The oldest flywheel on Earth is the potter's wheel. Mesopotamia, roughly 3,500 years before the Common Era. A heavy stone disc on a central post. The potter kicked it, and the mass carried the rotation between kicks. That is flywheel storage in its most ancient form. Mass at the rim. Momentum does the work. In the 1780s in Birmingham, England, James Watt bolted cast iron flywheels onto his improved steam engines at the Soho manufactory. The flywheel smoothed the piston's jerky power stroke into continuous rotation. Every textile mill and every foundry of the Industrial Revolution ran on energy stored in spinning iron. The technology powered Western civilization for a full century before the first commercial battery ever existed. In 1953, in Yverdon-les-Bains, Switzerland, the Oerlikon Engineering Company built something remarkable. A full-size city bus powered entirely by a 3-ton steel flywheel spinning under the floor. They called it the Gyrobus. It charged at stops by connecting to an overhead electric post for 30 to 60 seconds. Then it drove the next segment on stored kinetic energy alone. No batteries, no fuel, just a disc at 3,000 revolutions per minute. A second fleet ran in what is now Kinshasa in the Congo. A third operated in Ghent, Belgium. The program proved to the world that kinetic transit was a viable alternative to petroleum. In the 1990s, at NASA, Glenn Research Center in Cleveland, Ohio, engineer Ralph Janssen led a flywheel program designed to replace chemical batteries on the International Space Station. The prototype spun on magnetic bearings at over 40,000 revolutions per minute in a vacuum. Published data confirmed more than 100,000 charge and discharge cycles with 0 measurable capacity loss. 0. The program proved a spinning disc could outlast any chemical battery ever manufactured. Then NASA defunded it before deployment. In 2014, in Évry-Courcouronnes, France, an engineer named André Guénesseau founded Energiestro. His insight was simple: concrete, cheap, dense, and castable into large discs. He demonstrated that a pre-stressed concrete rotor reinforced with steel cable matched the storage economics of lead acid at a fraction of the material cost. Service life measured in decades. Meanwhile, in Union City, California, Amber Kinetics deployed steel flywheel units in Hawaii and Taiwan, proving long-duration flywheel storage worked at commercial scale. Both companies then struggled to secure the same federal subsidies lithium-ion manufacturers receive automatically. The physics was proven in the 1780s. Transit worked in the 1950s. NASA validated it in the 1990s. A French engineer proved concrete could do it cheaply in 2014. So why can you not buy a flywheel storage system at any American hardware store? Because someone made very sure you never would. The lithium-ion battery market exceeded $150 billion in 2025. Picture what that number requires. Cells engineered to degrade within 8 to 15 years. Cobalt pulled from mines in the Democratic Republic of Congo by hands that should be holding school books. Glossy advertisements promising innovation while building planned obsolescence into every unit shipped. Families opening utility envelopes at kitchen tables and setting them face down because the number keeps climbing and nothing they buy ever seems to last. Now picture the law that protects it. The Inflation Reduction Act of 2022 created Section 48E, a federal tax credit of 30% for residential energy storage. Early policy language heavily favored electrochemical storage. That single focus directed funding toward lithium-ion, lead-acid, and flow batteries, leaving alternative mechanical storage systems on the sidelines during the initial clean energy boom. A homeowner who installs a corporate battery pack gets 30% back from the federal government. A homeowner who builds a custom setup has to navigate a much harder path to get their project funded. In 2011, the Federal Energy Regulatory Commission issued Order 755. It restructured how grid-connected storage was compensated for frequency regulation. The new rules favored fast-responding batteries and financially penalized slower-responding flywheels. That ruling hit Beacon Power harder than anyone. Beacon Power in Steventown, New York had built a 20-megawatt flywheel plant, 200 individual flywheels in one facility. The technology performed exactly as designed. That same year, Beacon filed for bankruptcy, not because the physics failed, because the tax code and the market rules were written by people sitting in conference rooms across the table from battery industry trade groups. Picture those rooms. Lobbyists walking congressional hallways carrying projections showing factory jobs and domestic investment, all of it contingent on one thing: keeping the word electrochemical in every line of every federal incentive. The flywheel had no lobbyist in that room. The custom system spinning in Oregon has no trade association and no seat at that table. The dollar math tells the rest. A lithium home battery costs $8,000 to $14,000 installed and lasts 8 to 15 years. The homeowner replaces it at least once across a 30-year mortgage. A properly engineered flywheel system lasts indefinitely with simple bearing replacement every decade or so at a cost of $20 to $40. Every flywheel installed eliminates 2 to 3 lithium purchases that never happen. The industry that needs your battery to die cannot tolerate a device that refuses to. Now, if you do not own land, if you are not off-grid, if you are sitting in a suburban house or an apartment right now, stay with me. Because what comes next works in any home, costs under $300, and requires 0 permits in most jurisdictions. This part was built specifically for you. Here's the number I promised at the beginning of this video, the one calculation that changes everything. A Tesla Powerwall 2 stores 13.5 kilowatt hours of energy. It costs roughly $11,500 installed. It carries a 10-year warranty covering about 3,650 cycles. That works out to approximately 23 cents per kilowatt hour delivered over its lifetime. A homemade flywheel sized for supplemental evening storage handles targeted energy needs. It is enough to run efficient lights, a small fan, and a phone charger for several hours after sundown. It costs $150 to $300 in materials. The disc does not degrade. The bearings cost $20 to $40 to swap every 10 years. Over a 20-year service life, with daily cycling, the cost per kilowatt-hour per cycle drops dramatically compared to standard chemical packs. That is the hidden financial edge that makes mechanical systems so powerful. Now let me be honest about scope. A single flywheel does not replace a whole house battery bank. It bridges the gap between sunset and bedtime. It captures afternoon solar energy your panels produced that would have gone to waste. You can build multiple units and parallel them for more capacity, but this is supplemental storage for a solar-equipped home, not a full grid replacement. That honesty is what separates a real build from an internet fantasy. Here is how you build this yourself. You need one 55-gallon steel drum priced at $15 to $30. One steel shaft, 3/4 of an inch to 1 inch in diameter and 36 inches long, priced at $10 to $20. Two pillow block sealed ball bearings, $15 to $25 for the pair. High-strength structural polymer resin, $10 to $15. A carbon fiber reinforcement kit, $5 to $10. One salvaged permanent magnet direct current motor from a treadmill, $30 to $60. Belt and pulley hardware, $10 to $20. A charge controller, $20 to $40. A small pure sine wave inverter, $30 to $50. Wiring and connectors and a fuse, $10 to $20. Total, $155 to $290. 8 steps. First, weld or bolt a steel frame from angle iron to hold the bearings at a fixed height inside the drum. The shaft must spin freely at center with zero wobble. Second, build a circular plywood mold sized to fit inside the drum with clearance on all sides. Insert the shaft through the center and embed reinforcement near the outer rim. Third, pour a dense high-strength composite matrix mix around the shaft. Tap out air pockets. Cure for 7 days minimum. The finished disc should weigh 50 to 70 pounds. Fourth, mount the cured assembly into the bearings and verify free spin with no contact against the drum walls. Balance by grinding or bolting small weights to the light side. Fifth, mount the treadmill motor to the frame and connect it to the shaft through the belt and pulley. This motor does both jobs. It spins the disc up when fed power, and it generates electricity when the disc drives it during discharge. Sixth, wire solar through the charge controller to the motor input and wire the motor output through the inverter. Install a fuse and a meter. Seventh, secure a steel mesh lid over the drum top and bolt it down. Anchor the whole frame to the floor. The reinforced drum acts as your primary containment shield. Eighth, run your first spin up safely during peak sun and watch the speed build. Then disconnect solar and measure how long the flywheel sustains your loads. 3 safety rules you do not skip. The reinforced steel drum and thick protective lid are not optional. A spinning composite disc stores real energy and you want maximum structural protection around it. Check the assembly monthly for heat and vibration. Hot bearings mean misalignment. Shut down and fix before restarting. Keep hands, clothes, and loose objects away from the shaft and belt at all times. Treat this with the same respect you give a table saw. 2 notes that will save you trouble. Bearing friction means the flywheel loses stored energy faster than a chemical battery at rest. Expect useful output for 3 to 6 hours after a full charge depending on load and bearing quality. That makes this perfect for bridging sunset to bedtime. It is not the right choice for backup that sits idle for weeks. Round-trip efficiency runs 50 to 65%. Sounds like a drawback on paper, but your solar panels fill the batteries by noon, and every remaining hour of sunlight goes to waste. You are not losing power. You are storing power that would have vanished anyway. If this changed how you think about energy storage, subscribe to Off-Grid Ohms with Oliver. Please watch the next video appearing on your screen right now.